In this lesson, we will derive the trig identity for sine of a sum, sine of the quantity a plus b. And we will start by drawing two arbitrary angles for angle A and angle B, and we position them in a way where you can visualize the angle A plus B. Next, we're going to draw some right triangles in the figure to make use of right triangle trig. So taking a look at angle B here, B is an arbitrary angle, so we extended those rays as long as we needed to, and then position a segment anywhere along those rays where you can visualize angle B within a right triangle. Let's take this location and also draw a perpendicular straight down to the x-axis, so now that we have angle A in a right triangle, and we can label angle B being opposite a side B and angle A opposite a side A. Next, we're going to need another segment here. Let's draw a perpendicular straight down to the x-axis. This is an important one so that we can visualize a right triangle with the angle A plus B in it. And let's label the hypotenuse. We could label that hypotenuse another letter C. And let's go through and label some of the angles here. So we have the small triangle on the lower left with angle A in it, and the other angle is 90. That leaves us with the third angle being 90 minus A. Why is that the case? Well, angle A plus that 90 minus A must be complementary when your third angle is 90 degrees. Next, you have a vertical angle. This angle must be 90 minus A as well, because those two are vertical angles. And then the triangle up top, if we have 90 minus A with another angle being 90, that leaves us with the third angle being A as well, because the A plus the 90 minus A must be complementary angles. We're going to need to make use of one more triangle here, so let me draw one more segment here, which is perpendicular, and that gives us a triangle up top with angle A in it. We'll make use of that as well. So let's label some segments. We can call that segment X. And we're going to need to make use of this segment right here. Why don't we call that segment A? Notice that's the same segment A as the other segment A directly to the right. Those are both parallel and they're congruent segments, and so the same length. Okay, let's get started with our formula now. So we're going to set up sine of A plus B. Take a look at that yellow highlighted triangle. And sine of the angle A plus B, now we're going to treat as the opposite to hypotenuse, where the opposite side is going to be A plus X. We're going to have to add those two segments together to get the opposite side. And then we have to divide that by the hypotenuse. The hypotenuse we labeled as C. Next, let's do a separation strategy. We can separate this as A over C plus X over C. Since both of these are being divided by C, this is like a common denominator strategy. Reverse common denominators where you split them up over the same denominator. Next, we're going to have to make use of one more segment here before we do right triangle trig. I need to label one more thing, and I'm going to label this right here. This is the diagonal of one of the triangles. Let me label that diagonal D. So I know our diagram is getting a little crowded now. So, making use of that diagonal D, I'm going to do a multiplication trick here and treat A over C as the same thing as A over D times D over C. And the reason we're doing this is to split this into two trig ratios. And notice that those D's cross-cancel, so A over D times D over C is equivalent to A over C. Let's do another split here with X over C. I'm going to make use of another segment B here and write this as X over B times B over C. And think of those B's as cross-canceling. Now the reason I'm doing that is to make use of more trig ratios. So to get a closer look at what's happening here, let's give this a try. So first what we want to look for is A to D. Where can we find this A and D, and which triangle are they both a part of? So let's take a look here at this triangle. I'm going to highlight this one in green. So let's look for the ratio A to D in that triangle. Angle A is opposite side A, and D is the hypotenuse of that green triangle. So we can treat A to D as the ratio of sine angle A. So sine of angle A is opposite A over hypotenuse D. Okay, next, Let's verify where D to C is. That's another trig ratio somewhere in the diagram. So let's look for a triangle with D and C in it. Make sure it's a right triangle. D and C, let me do this one in blue. That would be this triangle with that diagonal and this triangle up top here that we just went over in blue. It has the angle B in it. D is adjacent to angle B, and C is the hypotenuse. So we're going to treat that as not sine of B, cosine of B. That has to be the cosine of B because cosine of B is adjacent D to hypotenuse C. Okay, and then next, let's look for X to B. Let me use this in another color here. So here we have in red, let's take a look at X and B. That will be this tiny triangle up top. Let's use this red triangle here. Making use of angle A, X is adjacent, B is hypotenuse. That must be cosine. Let's replace that with cosine of angle A now, because cosine of angle A is adjacent next to hypotenuse B. Okay, and here we have B to C. B to C is actually in one of the triangles we already used already. B to C, let's use this blue triangle again. Let me go over it one more time. Looking for, there's your side B, and then C is the hypotenuse. So side B being opposite angle B, we want to make use of the sine. Let's call this sine angle B, where sine angle B is opposite B over hypotenuse C. So there we have a visual representation for the sum identity for sine. So a good way to remember this is if you have sine of A plus B, you take sine of the first term, cosine of the second. Sine will keep the addition sign. And then you add that to cosine of the first term times sine of the second term. So that would be a helpful way to remember that formula.